Thank you, Don. And next up, we've heard it touched on a couple of times today, actually probably more than a couple, is the topic of big data. So I'd like to welcome Randy Hayes from DataDirect Networks to the stage.
Thank you. All right. Thank you, everybody. Appreciate everybody sticking around. This is a vendor presentation. However, it is not a commercial for DDN. I just want to let that. I've seen some of the other presentations this afternoon, and they seem to be kind of commercials for those specific products. So the goal of this presentation is to talk about big data, how it affects the government customers, the government institutes, and what people are doing to basically harness this big data type of architecture. So I have one slide on DataDirect Networks. I think that was all we were allowed from Deltek. So one slide to talk about a company. Raise a hand, how many people have heard of DDN or DataDirect Networks? About 7, 6, 10. How many people have heard of IBM, SGI, Cray, HP, Dell, Bull? All those major server manufacturers either OEM or resell our storage. So the question you probably have is, why do those companies, when they have their own storage companies, OEM or resell DataDirect Networks? It's because our company provides a service that their traditional storage architectures can't manage. Okay, it's a little slow. So like I said, one slide on DDN. The company's been around for 13 years. We are the largest privately held storage company in the world. We did over $200 million last year. Headquarters in Chatsworth. We do have a facility up in Columbia, Maryland. It's a technical facility. So our DC local customers like that very much. They can go up and hit the boxes, kick the tires from that perspective. Our key market segments, things that we focused on, high performance computing. We have 8 of the top 10 supercomputers in the world store their data on DataDirect Networks. 60 of the top 100 store their data on DataDirect Networks. If anybody raise a hand who watched SportsCenter this morning? So that was broadcast off DataDirect Networks via IBM, but it was a DataDirect Networks box. If you watched the Beijing Olympics 2 years ago, that was broadcast off DataDirect Networks. So you see kind of a trend in the type of customers that we support, and it basically goes around high bandwidth and data that always has to be consistently there at a consistent performance perspective as well. Gartner classifies us as a niche technology. So remember that. Remember when we talk about a little bit later in the presentation, we're a niche technology, $200 million niche technology. Some of the customers on that right-hand side, Oak Ridge National Labs has 40 petabytes of our disk. NASA Ames has 60 petabytes of our disk. NASA Goddard, I think Adrian's here somewhere, they have over 10 petabytes of our disk. So when you start looking at and around the government landscape, these mega data centers that are hundreds of thousands of spinning hard drives on the floor, typically they're a DataDirect Networks customer. The other thing I want to talk about, and I'm going to kind of give you guys a term, and you can take this for what it is, but it's 5 to 10 data. And you're probably like, what does 5 to 10 data mean? 5 to 10 data is something that I thought up when I was putting this presentation together. And it basically talks about when you leave your day job, when you leave your office, what do you do from 5 o'clock to 10 o'clock? You're probably watching videos on YouTube, you're checking your Gmail, you're checking Hotmail, you're talking, dealing with Facebook, looking at photos on Shutterfly, Photobox. These are the types of companies that the government needs to start talking to and understanding how they go about doing their business. By the way, those are all DDN customers, just as a side note. Those are the type of customers that the government needs to talk to and understand how they build their business and how they build storage architectures to support millions of people. When we talk about cloud, those are the original, cloud architectures. Remember, in 2000, Hotmail came out. It's kind of the original cloud architecture. Access it from anywhere, multiple people accessing that architecture, and that's been around for a long time. Now, big data gets thrown into the mix, and big data, seems to be, kind of the hot buzzword, like virtualization was a couple years ago, and grid computing is a hot buzzword. All your traditional storage manufacturers are going to have some sort of slide that shocks you. Oh, it's big data. When I see a slide like this, and you're going to see it for the government end users and customers that are going to bring in different storage manufacturers to have a conversation. You're going to see a slide like this, big data. When I see the slide, I feel like we're at the Verizon Center and it's, monster truck rally. Sunday, 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 watch them crash, watch them smash. You got big data versus data tsunami, right? Got everybody's attention now? I went down. Sorry. So let's talk about big data. Let's define it a little bit. I know there's a lot of different architectures, a lot of different terms for big data. What I'm going to go through is, kind of our perspective of big data. Everybody has their own perspective. Structured data, it's not that big. Most of the architectures, if you're looking at like an Oracle database, SQL, things of that nature, that's your traditional structured data. 100 terabyte database, huge database, right? It's not what we're dealing with. We're dealing with petabyte scale. A term we like to use, hyperscale, right? Getting closer to the big data type architectures, you have unstructured data, right? So this is your file generation, standard, back office files, things of that nature. There's a lot of companies that do this sort of thing, sit behind this architecture. It's getting there. Those are getting bigger. The PowerPoints are 10 megabytes, and the pictures are, getting bigger and bigger. But where the real shift and where the real big data is coming from is machine-generated data, right? So this is your, ISR sensors, right? You got, hundreds of predators at this point flying around the globe collecting data, right? Talking about genetic sequencing, right? The U.S. isn't just trying to kill everybody in the world. We're also trying to do a little bit of good as well, right? So we're providing this genetic sequencing architecture to, drive healthcare, right? So a genetic sequencer spits out 8 terabytes every time it runs. National Cancer Institute's got 20 of those, right? So every time you run one of those, they're producing a ton of data. And these are really what, is really what driving the big data type architectures is machine-generated data. When there are machines building and creating data when you've gone home and you've gone to bed, right? Those are the big data producers. So again, this is another, kind of big data slide talking about, one of the big, mobile devices creates a ton of data, right? The mobile devices that we have nowadays are so powerful. Just in the last couple of years, the amount of storage and the amount of data, and you can see from the telco providers, they're really struggling with the amount of data that's being built and generated by these mobile devices. Case in point, AT&T, Verizon, a lot of these people are basically bottlenecking the different mobile devices so you can only access so much data at a certain given time. So, major film production. Right now we have 3D, right? Okay, Avatar took a petabyte of disk to put down that. And then, oh, by the way, they have to do all of the animation and everything else that's built into that CGI. It's 3 more petabytes of disk, coming out of New Zealand. We talked about, the sensors as well. So I don't really have to, most of you in this room, I don't have to tell you about big data, because if you go to your storage architects, they got a graph that looks just like that, right? Straight up. Here's where the data requirements are going in the next, 5 to 6 years. They're going straight up. And you need to look at different types of storage architectures that can handle this type of data, right? Storage is a commodity. Everybody, in 2020, you're going to be able to buy a petabyte for $10. Fact, right? So imagine that. Petabyte for $20, maybe $100. 7 years. The data growth is going to continue to go. It's not, hey, great industry for us to be in, right? Data continues to grow. But it's how you manage that data, it's how you access that data, it's how you make something out of that data. I was at a customer site not that long ago, and they said, our biggest problem is we don't know what we know. So think about that. We don't know what we know. This is an intelligence agency. hundreds of petabytes of data. They don't know how to use it. They don't know how to manage it. They don't know how to add it all up, put analogies, put architectures behind where they can actually use that data. So this is something that's coming to the forefront, and we're just peeking into this on the federal side. Again, this goes back to 5 to 10 data. You need to go and talk to some of the customers. You talk to Amazon, talk to Google, talk to YouTube. People have children that play Xbox Live, Call of Duty, Modern Warfare. I still play. Sorry, I'm not a gamer. That being said, you want to talk about pushing data out to the edge. That's a technology that needs to do it. Granted, it's a DDN customer. But you've never seen somebody get more angry than when they have some sort of issue with that software, and from no fault of their own, they get shot and killed in this video game. Kids hate it. It kills them, right? So, but Microsoft has built their whole architecture around that service provider, right? So providing a service to be able to play video games online. Again, another big data architecture. So what does everybody want, right? So what do the users want? What do the CIOs want? They're kind of aligning up, right? They need to talk to each other a little bit more, but they're aligning up, right? So global collaboration, simple data sharing, right? Again, go think back to your 5 by 10 data, right? Google doesn't have a problem sharing data, right? You access Google from anywhere in the world, any device in the world, right? Same with Amazon. You can access a website anywhere you want. Global collaboration, 5 to 10 data, not your 8 to 5 data. And there's different manufacturers that support this architecture. So your traditional SharePoint and your database manufacturers that are supporting storage behind that, those aren't on the forefront. These vendors out here that are out in this hallway that are niche players, those are the guys supporting this architecture, the Web 2.0, the big data, the high-performance computing architecture. So it has to be scalable, right? Why? Well, why does it have to be scalable? Because budgets are going down, the manpower in the federal government is going down, storage keeps rising, so you need to figure out a better way to manage disk. We talked about storage cost, right? It's a commodity. The fact that it's a commodity, it's fine. You can have petabytes and petabytes of data. That's not where the cost is. It's managing that data. It's making that data useful. That's really where the architecture is at. And then mobile device access. So compliments of Dell Tech, they do a great job looking at all the different CIOs and looking at the different architectures and talking to the government end users and giving industry some feedback around, here are some of the things that we're looking at. Mobile devices is all over the place, right? Data consolidation, all over the place. Now, there's a fundamental problem with both of those, and the fact that government wants to consolidate, but they want to do mobile and telework. Okay, that makes sense to a point. Financially, it looks great on the spreadsheets, but when you start taking that data and having it centralized, but your workforce is out here, data's here, now you're dealing with a lot of network issues. Now you have to pull data from multiple locations, right? So the general thought process that the government is moving forward with works, but they have to start looking at these internet-based companies, these companies that do it for money, for profit. So I encourage the government folks that are in this room to go talk to some of these companies that are growing, that are exploding, that you didn't even know what they did 5 years ago, or there wasn't even a market for what they did 5 years ago. But these are the people that are buying the architectures from vendors that are out there, the forefront. So not all data architectures, one size doesn't fit all. You're looking at something that's, every vendor has a scale out, scale up, we can scale performance, we can scale capacity. There's a couple other issues with that. You have to be able to scale bandwidth for big file applications. You have to be able to scale IOPS independent of each other or at the same time. So remember I talked about niche company, Gartner, said we're a niche company. So if you look to the left in this triangle, HPC Web 2.0, this was kind of a small architecture. The HPC community, tight-knit, very close because there weren't that many people doing it. Now everywhere you go, people are doing high-performance computing. Compliments of Red Hat, they make clustering really easy now. So the traditional storage vendors are, down here, your enterprise Fortune 1000s, maybe a little bit of the mid-range, but that's where the big architectures were. They were supporting Oracle and SQL and Exchange. Oh, it has to be 100% up all the time, right? So that's what they focused all their time and effort on, were these business applications, because industry and customers said, we need access to email 100% of the time. Well, you get email access 100% of the time from Gmail and Hotmail and Yahoo for the most part, right? So there's been a change. You look at this hyperscale, flip the storage industry on its head. You look at all the acquisitions that have been going on lately. I don't have to name names. You guys all know the major storage players in the industry. They're buying companies like crazy because they were initially focused on the traditional Fortune 1000 enterprise applications, right? Snap this, snap that. We can do all this cool stuff with Exchange. Great. Exchange database is, 20 terabytes, 30 terabytes. It doesn't help us when we're talking about 20 petabytes. So now, these niche companies, that were doing HPC 2.0 are now running the show. They're coming to us. Again, go back to why all those large companies resell or OEM our storage, right? And it's not just us. There's other players in there. Like I said, I'm not trying to make this commercial about us. I'm just trying to make you guys think about the other architectures that are out there other than the traditional storage manufacturers. Because they're all trying to buy companies and bolt them on versus having the thought process of building an entire company around big data. So, paradigm shift. You guys may know this, you may not. I'm here to tell you about it a little bit. It's object-based storage, right? Traditional file systems, they were built early 90s, right? Talking about 16 terabyte global namespace back in the early 90s. Now it's 256 terabytes. Big deal. Magnitude of 16 in 20 years. It's not going to fix. It's not going to work with a large architecture. Hundreds of petabytes. I mean, that's what we're talking about. Some of the intel agencies talk about exabytes of data. How do you manage that? How do you store that? How do you power that? How do you cool that? Right? There's a lot of challenges when you're dealing with big data. The software is just a portion of that. But if you have to implement 10 times the amount of storage just because you're locked into a traditional POSIX file system that inhibits a lot of the things that these internet-type companies do, 5x10 data. Those companies, this file storage is built from your 9-to-5 type data. We're going to use SharePoint. We're going to use Exchange, Oracle. It's great. Great products for that stuff. But now you're trying to jam a round peg in a square hole, and it's not necessarily working so well. So this is, granted, this is a marketing slide. You got horse-drawn carriage and some sort of fast Euro train. And that's probably not even doing it justice. File storage should be, maybe a turtle. Object storage should be like a space shuttle. I mean, that's a difference as far as the size of magnitude of the performance that you're going to get out of something that's running on object-based storage. This is not proprietary to us. There's other companies that do object-based storage. So again, not a commercial for DDN. But one of the big things with object-based storage, if I could sum it up in one analogy, it's basically like valeting your car. And some people probably valet their car out front, right? So you show up, you give them your car, they give you a ticket, you assume that they don't do something like Ferris Bueller and drive it all around town and wreck it into something. But when you come back and you give them your ticket, you get your car back. That's what object storage is basically all about. It's a completely flat file system. And really, there's no file system, right? You're using some sort of database architecture that allows you to have billions of objects or billions of files in a single global namespace, in a distributed global namespace. So a couple of, talking about cloud, we talked about object-based storage. Cloud architecture, I think I'm getting the yank here in a little bit, so I'm going to jump through a couple of these towards the end. But so what are the requirements? We had a great discussion from Dawn around some of the requirements and things that are being built out around cloud storage. It's in its infancy. I mean, cloud storage as a solution is 2 years, maybe 3 years old. Some of the companies, DDN has been doing it a little bit longer. But what are just some of the things that are on there, right? accessing many from many locations, geo-distributed, accessing these things from anywhere in the world, global distribution, high resiliency. You want to know when you put it out there that it's going to be there when you go to get it, and easy to manage. That's the biggest issue with storage right now. Easy to manage. It can be cheap. Again, storage is a commodity. Easy to manage. So I'm getting beeped at. Conventional NAS, we talked about a little bit, can't really get there. Right? Again, 16 terabyte global namespace in the 90s, it's up to 256. There's a couple of companies that can make it a little bit bigger than that, but traditional NAS architectures are not going to be able to handle this architecture. Some of them are bolting object-based storage on top of their NAS architecture. Okay, you're still dealing with all the complexity of the traditional file system, and now you've put more complexity on top now that you've added object-based storage onto it. So you need a true object-based storage architecture. We talked about this a little bit as far as this flat namespace, object. Just go back to the analogy. If you take anything away from this analogy, it's valeting your car. Give your car, get a ticket, take the ticket back, give the ticket to the valet, get your car back. That's as easy as it can be explained as far as object-based storage. And you can do that up to 256 billion times. And I believe this is my last slide. So benefits, I'll run them down real quick, because I know I'm out of time. True end-to-end object storage. You need a true object-based storage. It can't be something you're bolting on to a traditional manufacturer. Maximum performance from every media. That goes from the same type of thought process. You can't take object storage and bolt it on top of a traditional storage architecture. Easy to manage. Self-healing. Our Intel customers love this because they can shove it in a container, ship it into the sandbox, and not have to worry about it. Fills itself. Flexible access. Open API. You can access it via the web. You can access it via directly your application via C, PHP, HTTP. You could add standard NAS protocols over the top of it. And I added that last one. Plays nice with others, right? That's one of the things to keep in mind. There's a lot of manufacturers out there that are, you need to buy the whole stack from us, and then it works great. Do you really want to buy the whole stack and get locked into a specific architecture? Play nice with others. Be able to integrate with your architecture. I think that's all I had. Do I have time for questions? Yes. 0 time for questions. Do we have any questions? So you guys know everything there is to know about object storage? Okay, my job's done. Thank you very much.
So sorry, excuse me. How are you addressing security and the security aspects of storing an object?
Yep, absolutely. So just quickly, all the objects are encrypted at a 256-bit level. So the object ID or that ticket that you give, is that me or you? When you get that ticket back, that object, that ticket is encrypted at a 256-bit encryption level. So unless you have that exact encryption key for that object ID, you can't access the object. So as far as in motion, a lot of that's done around some of the network switching and things like that, but there is security built into a lot of this architecture. This, at least from our perspective, is a private cloud architecture, so it's behind your firewall. So you buy it, you manage it. Again, going back to easy to manage, right? So it's behind your firewall. We do have things where we play nice with others, where you can integrate into S3 and things like that if you want to have a hybrid public and private cloud, where some of the data doesn't belong up in a public cloud, but some of it, but you like to use that architecture. Does that answer your question? Okay.
Randy, I know we spoke earlier, but what are you guys using to scale out? I mean, what is your metadata or database structure that allows you to point manage these objects?
Right, absolutely. So the object management is actually done in, we call them nodes, if you will. So the software is built into the actual physical device. And that node, in this case, has 60 hard drives in a 4U architecture. And then each one of those nodes has basically a data map. And it knows where all those objects are down to the block and sector level of every drive, in every node, in every location. So that all continues to go back and forth over gigabit Ethernet, 10 gigabit Ethernet, or InfiniBand.
Following that, do you guys have integration with Hadoop?
So we don't today. It is in the process because our general, thought process. If you think about what Hadoop is, it's basically, the MapReduce type of architecture. You want to be able to push data out to multiple locations. If something fails, you can replicate it. All that is already built into this architecture. So you don't have to create a science experiment with Hadoop. I mean, Hadoop is a real hot word right now, but the fact is there's only 1 or 2 government agencies using it. Now, don't get me wrong, it's a great architecture for some companies, right? So that's how Amazon tracks what you're buying, what they're looking at. You bought a weed whacker, well, here's, oil and trimming string for that weed whacker, right? That's how they do that type of architecture. So I'm not saying anything negative about Hadoop, it just doesn't fit every single cloud architecture from that perspective. And those, outages that S3 had, that was caused by trying to move too much data around because of Hadoop. So, or that sort of architecture. Okay, I'm glad I woke everybody up from their 2 o'clock nap. So consider me your 5-hour energy drink. So, thank you.